All right, so again, we're moving on. We've talked about the tangent ratio for several days last week where we were creating the right triangles. We were looking at that ratio. But today's where we're actually going to bring it together and we're going to start looking at how do we use the calculator for part of that. Some of that, today what we're going to do is the same thing we were doing last week, which is just dividing to find that ratio. But again, I am also going to teach you how to use the calculator. How does that tangent function work? And what are some things that I need to make sure that I check every time I get in to my calculator to make sure I'm going to get the right answer. So first, the tangent ratio, again, is the ratio of two sides of a right triangle. The side opposite the given angle and the side adjacent to the given angle. Now, the given angle, we've been calling this the reference angle. So when they talk about the given angle, we've been referring to it. So, hey, that's really what we're calling our reference angle. So there's some angle that they've asked us to look at this triangle from. That becomes that reference angle. That's how we're going to look at that triangle. Now we have our right triangle here. I'm going to draw in my square to show that that is a right triangle. We should know that the hypotenuse is the side opposite the right angle. And what we're doing today is not going to involve the hypotenuse, but we still need to know where it is so that we are labeling the other parts of our triangle. Now, there is a Greek letter that is used in place of angle measures. It's the Greek letter theta. And really, it kind of looks like an O that we swoop back around and cross over. So you draw your O, and as you come back around, you kind of swoop through it again. That is the Greek letter theta. And it's something that mathematicians started using many, many years ago because it's such a unique letter. So they use that in place of an unknown angle measure. So if we say the tangent, and when I say the word tangent, when I write it, I'm only writing the first three letters. The tangent of theta. So again, this right here is the Greek letter theta, Theta. And again, because it's so unique, it's just something that they've used as a placeholder. Something we call a variable now. They were using the Greek alphabet, obviously, when a lot of this was formed. So theta, because of its uniqueness, was a Greek letter that they use in place of an angle measure. So it's still really just a placeholder. It's just a variable. But I want to start using it because on standardized tests and whatnot, a lot of times they will put the Greek letter theta in for an angle. And I want you to know what that means. That you see that and go, oh, it's just a variable. I need to find that angle. So if I put theta down there, then this obviously becomes my reference angle. And we said that the tangent ratio is the leg opposite divided by the leg adjacent. And again, that opposite and adjacent refer to where is that reference angle? Where is that theta? Because that's what we're looking for. So across from it, we would call that opposite. Next to it, we call that adjacent. And it's very important that we understand that hypotenuse is not involved in the opposite or the adjacent. Hypotenuse already has a name. It's the hypotenuse. So we have to understand, where is that reference angle? What is across from it? That represents my opposite. And what is next to it? That represents my adjacent. So that's where that ratio comes in. Now, the very next part, it says find the value of the trigonometric ratio to the nearest 10,000th. Before we do that, I need to teach you a little bit about the calculator with those ratios and some things we need to look out for. So I'm going to switch over to my camera so I can bring in my calculator here. Maybe. All right, so we have our calculator. This is very, very important. In order for you to get the correct answers, your calculator has to be in degree mode. Now, your calculator has 3 different modes. It has gradients, radians, and degree. If your calculator is not in degree mode for what we're doing, it is going to give you the wrong answer. Now, as you move up into other levels of math, that's where you start to use those radians and gradients. We only deal in degrees here. That's all we're concerned with. So how do I know if my calculator is in degree mode? It depends on the calculator, but like this one, I can see the D there, up here on the top of the screen. Some calculators will actually write out the word degree, and some calculators will put DEG. If you're not sure, an easy test to see if you're in degree mode. So you have your sine, your cosine, and your tangent keys. If you hit your sine key, the SIN, and then you type in a 30 and finish your parentheses. If you type in the sine of 30, you should get an answer of 1/2, either 0.5 or the fraction 1/2. They're the same thing. If you don't get 0.5 or 1/2, your calculator is not in degree mode. So that's an easy check. You can always go in and do sine 30. Okay, I got 1/2. I'm good to go on my other calculations. That is a way to test. But if you do not check that and you start doing calculations and your calculator is not in degree mode, then you're going to get wrong answers. Is there anyone that needs help with checking their calculator for degree mode? All right, so the first set of problems here. All right, so the directions say find the value of the trigonometric ratio to the nearest 10,000th. 10,000th means we're going 4 decimal places, which means we really have to look at the 5th number to see if we round up or keep it the same. So the first one says tangent of 6. So I'm going to go to my calculator and I'm going to put that in. I'm going to clear it just so you can see. So I'm going to look for my tangent key. I know I've hit the right key because it says tangent. And then I'm just going to type that 6 and finish my parentheses. Now, if you have a single line readout calculator, you do have to enter this difference. So if you have a single line readout calculator, let me know and I will show you how you have to input this for that single line readout. Anyone that's using my calculators are all multi-line readout, because you have a line here and you have a line here. Single line readout means there really is just one line of readout on your calculator. Does anybody have a single line readout calculator that they're using? So what do we get when we hit equal here? Okay, but we want 4 decimal places. We got to pay attention to what they're asking for. 4 decimal places, so we're going to put 0.105. 1051. We're going to go 4 decimal places. That fifth one in this case is a 0, which says, hey, just leave the number where it's at. So we're going to take those first 4 numbers, 0.1051. That is the ratio representing the tangent of 6 degrees. Okay, the tangent of 75 degrees. Again, this is just about making sure we're using the correct keys on the calculator. So again, I hit my tangent, type in my 75 in my parentheses. And then I hit return. So again, I need 4 decimal places here. What would this decimal be? .7321. That fourth number is a 0. Again, so the tangent of 42 we put that in the calculator. Again, tangent 42, finish my parentheses. What is the decimal I'm going to use for the tangent of 42? Yeah, 9004. The fifth number is a 0, which says leave it alone. So I'm just going to put that down as my value, 0.9004. Now, the next section does not involve using the tangent key. I don't want you to think that every time we're talking about the tangent function, we are automatically using the tangent key on the calculator. That time they were asking for the ratio of a specific angle measure, so we were using that key. These next set of problems are still finding the ratio, but it's using a specific triangle. So the first one wants to know about the tangent of angle A. So I see angle A on my diagram here. So that A becomes my reference angle. And is my reference angle to determine opposite and adjacent. So across from that angle or opposite it is going to be that 12, and next to it is going to be that 35. Again, 37 is the hypotenuse, so it's not the adjacent. The 37 has a name already. So the tangent of angle A equals that 12 divided by 35. So you are just simply doing 12 divided by 35 in your calculator. You are not doing the tangent key at all. This is just telling us what that ratio is, and they want it rounded to 4 places. So again, we are just simply doing 12 divided by 35. We are not using the tangent key here, just 12 divided by 35. Again, if your calculator is in math mode, it's going to give you a fraction at this point. If it does, remember we want to find that S to D key. That'll take us from standard to decimal. So if it is in math mode and is giving you a fraction, just hit that key and it'll get you the decimal. Again, we want to round this to 4 decimal places. So the fourth number here is an 8. The fifth number is a 5. Am I going to round up or leave it the same? Round up. So this is going to become 0.3429 is the ratio. So 0.3429. Again, this does not involve the tangent key. We are simply doing a division problem on our calculator. The next one wants the tangent of C, so I find angle C on my diagram, and I know that's going to be my reference angle. And that's important because my reference angle really helps me determine what is opposite and what is adjacent. So in this case, opposite or across from it is the 36. Next to it is the 27. So the tangent of angle C is going to equal 36 divided by 27. So the tangent of C equals, what do I get when I divide 36 by 27? 1.3333. The fifth number is also a 3, which would tell us to leave that one alone. So we get 1.333. Number 6, the tangent of Z. So again, Z is my reference angle. So across from it is the 28, that becomes my opposite. Next to it is the 21, that becomes my adjacent. So the tangent of Z equals 28 divided by 21. So what do I get for my decimal for 28 divided by 21? 1.3333. Because 36 over 27 reduces down to 4 over 3. 28 over 21 reduces down to 4 over 3. So they're both the same ratio. Even though we started with different side lengths, what that's telling me is angle C in number 5 and angle Z in number 6 are the same angle measure because they have the exact same ratio. Now, how can I use this information to find an angle measure that I don't know? And that's where another function on our calculator is going to come in to help us. So the tangent ratio doesn't change as we move from finding the ratio to finding the angle. So we still have our right triangle. I'm going to put theta in a different position this time. I'm going to put it up top. So this is going to be our reference angle. And the only reason I'm doing that is so you can see the reference angle in different positions. So you don't think the reference angle is always at the bottom of the triangle. It's wherever they're talking about. And again, we know that opposite the right angle is our hypotenuse. That hasn't changed. The only thing is tangent doesn't use hypotenuse. Tangent only uses opposite and adjacent. So across from that reference angle, which would be its opposite, is this side down here. And then the one next to it is its adjacent, would be here. So we said a little bit ago that this is represented by the tangent of theta equals leg opposite divided by leg adjacent. But I don't want to know what the tangent of theta is when I'm trying to find out what theta is. That means I need to move the tangent from one side of the equation to the other. When we do that, because the tangent of theta is really like a multiplication problem, we would have to divide. And when we divide something and move it to the other side, if we want to take it out of the denominator, we use that exponent of -1. And that's what happens here. Theta is equal tangent to the -1, which we call the inverse tangent function. So this is called the inverse tangent function. And then in parentheses, we put what we already had, leg opposite divided by leg adjacent. So when theta is by itself, we are solving for the angle measure. So tangent theta helps me find a ratio. The inverse tangent function helps me use that ratio to work backwards and find the angle measure. And this does require our calculator. And I'll talk about that in just a moment. All right, so if we go to the next page and look at the examples here, it says find the measure of the indicated angle to the nearest degree. And they will do this a lot. When they're asking you to find an angle measure, they'll ask you to find it to the nearest degree. If they're asking you to find a side length, they'll usually ask you for the nearest tenth. So here, we're going to round to the nearest whole number. So if they're telling us that the tangent of B has a ratio of 0.2126, that means that B has to equal the inverse tangent, so that tangent to the -1, parentheses 0.2126. And now I'm going to show you how we can use the calculator to find that out. Okay, so I'm going to switch to my camera real quick so we can see the calculator. So if you look above your tangent key, and I know this doesn't show real well right now because I'm using a dark blue calculator, but above my sine, my cosine, and my tangent, there's each of those to a -1. Those are the inverse. Anything in that color, I have to find the key with that color. In my case, it's the shift key. So if I do shift and then hit my tangent, you notice my -1 comes up. When I'm solving for an angle, I need to make sure that that's on my calculator, that I have tangent to the -1. They told me the ratio was 0.2126. I'm going to put that ratio in that parentheses, and I'm going to finish my parentheses. So you do shift, tangent, and then put in the ratio. And if I hit equal, I get 12.00238123. But they said round to the nearest degree. So what is the answer I'm going to put on my page? If they're saying to the nearest degree, they're saying to the nearest whole number, which means they don't want a decimal. So what am I going to put as my answer? 12. The first decimal is 0, which says, hey, leave that 2 alone. So we would say that the tangent of B is 12 degrees. So an angle that is 12 degrees has a tangent ratio of 0.2126. Number 8, the tangent of U equals 2.9042, which means that U has to equal the inverse tangent function of 2.9042. Sorry, So we're going to use the calculator again. We're going to use that inverse tangent function. I'm going to switch over for a moment here. Clear that out. So I'm going to do shift tangent, and I know I've done it correctly because I see that -1 power. Then I'm going to put in that 2.9042. End my parentheses. I should see everyone practicing this along. And then if I hit equal, this time I'm getting 70.99993394. Again, they are asking me to round to the nearest degree or the nearest whole number. What answer am I going to put on my page? 71. That first 9 says, hey, we need to round up. So I'm going to put an answer 71 degrees. Number 9, the tangent of V equals 9.5144, which means that V is going to equal the inverse tangent of 9.5144. So if I put that in my calculator, rounded to the nearest degree, what is my answer here? You should get 84 degrees. Now, that's if they just give it to me in that form where they already give me the ratio. If they give me a diagram, then I have to find the ratio and use that. But you're going to see, I'm going to let the calculator do all the work at the end. I'm not going to take the ratio, turn it to a decimal, then do the inverse. I'm going to show you how we're going to let the calculator do all the work for us. And the reason for that is the less we round, the more accurate the answer is. The more we start rounding in the little parts, you're throwing off the answer because now you're using approximations. If we let the calculator do all the work and we round at the end, that means we're getting the most correct answer. Obviously, if we're rounding, we're never getting an exact answer because we're rounding it. But we're getting the closest thing by letting the calculator do all the work. First, I'm going to change all these question marks to thetas. I'm going to try and be consistent here. And again, the theta is really just an O with the swirl back in as you come across the top. So on number 10, they're only giving us 2 angle measures. We know our reference angle is theta. Across from theta would be my opposite. Next to theta would be my adjacent. So this sets up that the tangent of theta equals the opposite of 36 divided by the adjacent of 36. But again, I don't want to know what the tangent of theta is. I'm trying to find out what is the value of theta. So that means that theta equals the inverse tangent of that 36 divided by 36. Now, what do we know about triangles, especially right triangles, where the legs have the same measure? What type of triangles do we call those that have legs with the same measure? You guys need to be able to tell me, what do we call a triangle that has 2 legs that are the same measure? So any triangle that has 2 sides that have the same measure is an isosceles triangle. Since this is a right triangle, it would be an isosceles right triangle. We also said that an isosceles right triangle had to be what had to be the angle measures for our isosceles right triangle. They were the same. It's one of our special right triangles. 45, 45, 90. I'm going to show you, the calculator is going to tell you this angle is 45 degrees. So when we go to our calculator to put this in, so again, I want to start with that inverse tangent. So I'm going to do shift tangent. And again, I know I've done it correctly because I can see that -1. And then I'm just going to put in my parentheses, my 36 divided by 36, and I'm going to end my parentheses. Now, I know this should come out to be 45 degrees. Is that what I get? Yeah, because anytime the legs of a right triangle are the same measure, that means you have an isosceles right triangle, which means you have a 45, 45, 90. And this proves it right here. The legs are the same. The inverse tangent function tells us, hey, that angle is 45 degrees. So in this case, theta equals 45 degrees. Number 11, here's my reference angle. Which means the 30 is the opposite. The 18 is the adjacent. So the tangent of theta is 30 divided by 18. Opposite over adjacent. And again, I don't want to know what the tangent of theta is. I just want to know theta. So theta equals the inverse tangent of 30 divided by 18. And again, I'm going to let the calculator do all that work at once. I don't care what the ratio is for 30 divided by 18. I'm going to let the calculator tell me, figure that all out at once. So again, shift tangent, and then I'm just going to put in 30 divided by 18 parentheses and let the calculator do all that work at once to tell me that what am I going to put for my answer here? 59 degrees. So theta is 59 degrees. So number 12. Now, what is different about number 12 from what we have seen so far on the other two, 10 and 11, is they've added the measure of the hypotenuse in. And they've done that just to make sure we are paying attention and getting the right measurements. We need to know that the 90 is not part of the tangent, because tangent is always opposite over adjacent. So opposite of theta is 54, adjacent to theta is 72. So this should be setting up that the tangent of theta equals my opposite of 54 over my adjacent of 72. So theta is going to equal the inverse tangent of 54 divided by 72. So again, I'm going to switch over to my calculator. So I'm going to do shift tangent, and then I want to do that 54 divided by 72, end my parentheses. Let the calculator figure it all out at once for me. And what is the measure of this angle? 37 degrees. Yeah, you get 36.8. That 0.8 says, hey, you need to round up. So this should be 37 degrees. I'm going to pause for a moment while you complete 13, 14, and 15, and then we will check your answers. All right, so as we look at 13, 14, and 15, again, the setup is similar to 10, 11, and 12, but again, they did give you the hypotenuse here, so you have to make sure that you understand opposite and adjacent. I changed all my question marks to theta. So in this case, in number 13, 21 is my opposite. 28 would be my adjacent. So the tangent of theta equals 21 divided by 28, which means that theta is the inverse tangent of 21 divided by 28. And rounded to the nearest degree, what did we get for this angle measure? 37 degrees. Number 14, again, theta is going to be my reference angle. Which means 36 is my opposite, 27 is my adjacent. So the tangent of theta is 36 divided by 27, which means that theta is going to be the inverse tangent of 36 divided by 27. And what did I get for my angle measure here? 53 degrees. And then number 15, again, theta is my reference angle. Making 24 my opposite, 45 my adjacent. So the tangent of theta is opposite of 24 over adjacent of 45. So theta equals the inverse tangent of 24 divided by 45. And what did we get for the angle measure? 28 degrees.